Let's look into how salts can act as acids. So far we have looked into specifically acids and bases that were not really salts. They were aqueous solutions of compounds that are defined as acids and bases. Whereas now we'll look into how salts can act as acid. By salt, what we mean is essentially ionic compounds. So ionic salts, for example, if you have a salt like NaCl, that is an ionic compound and it's a salt because it consists of a cation and an anion. Another example would be you can pick anything, K2CO3, potassium carbonate, that is a salt, ionic salt. So these salts can also act as acid and bases. How? If you take this salt and you dissolve it into water, you make basically an aqueous solution that can act as an acid or base. Now, how can we predict if a salt solution is going to be acidic or basic? That is what we are going to look into in this particular video. Okay. So all these salts, if you look at these different salts, they always consist of two components. One is the cation, which is the positively charged ion, and the other component is the anion, which is the negatively charged ion. So they are always composed of two ions. For a salt solution to act as acidic or basic, first thing is it has to be aqueous, meaning it should dissolve in water. As soon as it dissolves in water, it would dissociate to produce ions. And now we are going to look into if these ions are going to, how these ions are going to interact with water, and if that is going to produce a solution that is acidic or basic. Okay. Now, cations usually act as acids. If they do, they are going to act as acids. Anions usually will be acting as bases. How do you know which cations are going to act as an acid? So for that, just know these rules. If a cation is coming from a strong base, it is too weak of an acid to influence the pH of a solution. What that means, like I said, cations are going to act as acids. So cation meaning if you have Na plus, that's a cation. K plus, it's a cation. Ammonium, that's a cation. Okay, calcium 2 plus, that's a cation. So all of these are different types of cations which are supposed to act as acids. Okay, so for these cations you're going to figure out which type of acid or base do these cations come from. For example, sodium, you might have heard sodium comes from a base which is sodium hydroxide, NaOH, right? We don't know any acid that has sodium in it. So sodium comes from sodium hydroxide, which is a base. And what type of base it is? It is a very strong base. So a cation that comes from a strong base is too weak to affect the pH, meaning because NaOH is a strong base, sodium ion is not going to affect the pH. This solution that consists of Na plus ion, only Na plus ion in that solution is not going to affect the pH, meaning it's not going to be acidic nor basic. Similarly, potassium ion comes from KOH, it comes from a base. This is also a strong base. So because it's a part of a strong base, this potassium ion is a very, very, very weak conjugate acid. Okay, remember bases produce conjugate acids. So this is a very weak conjugate acid because of which it does not affect pH. So cations that are coming from strong bases are very, very weak to affect the pH, whereas cations that come from weak bases, they are going to act as acids. Example, NH4 plus. If you look at NH4 plus, where is it coming from? It's not coming from an acid. There's no acid that consists of this, but we know there is a base which is ammonia. Ammonia basically can produce ammonium ion. So this is a weak base, which means the cation of this weak base is going to be a weak acid, conjugate weak acid. Because this is a weak acid, it is going to affect the pH. And how will it affect the pH? It will be an acidic solution. So basically what you're looking for, remember cations are always going to make a solution acidic. because they are the conjugate acids of a base. Now, if the cation is coming from a strong base, it is going to be the pH of the solution is not going to be affected. If it comes from a strong base, it is a very, very weak conjugate acid. If it is coming from a weak base, it is going to be a weak acid which will affect the pH. Okay? Same concept applies to anions. Anions usually act as bases. If they are going to affect the pH, they will be making the solution basic. How? Same concept. If you think of anions like Cl minus, okay? Cl minus, Br minus, oh, Br negative, these are anions that are usually part of an acid. If you think Cl minus, where you might have heard of this in an acid or base, is HCl. So this anion is coming from a very strong acid. This is a very strong acid, which means this conjugate base is a very, very weak base. Very weak. Very weak conjugate base, which means this is not going to affect the pH. Similarly, Br minus comes from HBr, which is again a very strong acid, which means Br minus is going to be a very weak conjugate base that will not affect the pH. On the other hand, if you take any other anion that is not coming from a strong acid, for example, if I say CO3, 2 minus, this is carbonate ion. Carbonate ion is coming from an acid called carbonic acid, H2CO3. This is a weak acid, which means this right here is a weak conjugate base. So this is going to affect the pH. How? It will make the solution basic. That is how you figure out if your cation or anion is going to make a solution acidic or basic. So you will have to split your salt into cation and ion, figure out where each of these are coming from, and does that make them a conjugate acid or a conjugate base that can affect the pH, or it will not affect the pH. Okay. So let's try a couple examples. For example, NaNO3. How can you tell if this is going to, what type of solution it is going to make? So you can see from the title, this is going to yield a neutral solution. Okay, now how will you identify that? Sodium. What are the two ions that this will give? Sodium ion and nitrate ion. Where does sodium ion come from? NaOH. Where does nitrate ion come from? Remember, these always come from bases. These always come from some acid, HNO3, nitric acid. This is a very strong base. How do you know? You have to memorize these strong acids and strong bases. There's only 6 of each. And this is a very strong acid. So let's focus on one first. So Na plus comes from a strong base, which makes this a very weak conjugate acid. This is strong base, so this is a conjugate acid of it, which is a very weak conjugate acid, which means does not affect the pH. Does not affect pH. Similarly, this is nitrate ion, which comes from nitric acid, which is a very strong acid, which means this is going to be a very weak conjugate base. So it's very weak, which means it will also not affect the pH, which means your solution is going to be neutral. You do not have an acid in there, you do not have a base in there, so your solution is going to be neutral. That is the process that you will follow to figure out if a salt solution is going to be acidic or basic. Okay, let's try another example. Ammonium chloride. This is gives me ammonium ion, chloride ion. Ammonia comes from ammonia, which is a weak base. Why? Because it's not part of the 6 strong bases that you have memorized, which means this is a weak base, which means this is also a weak conjugate acid. So your solution will be acidic because of this for now. But we also have to confirm the next one. This is chloride, which comes from HCl, which is a strong acid, which means this, if this is a strong acid, its conjugate is going to be a very weak conjugate base. This is an acid, so this has to be conjugate base, and this is strong, so this has to be very weak, which means this is not going to affect the pH. Does not affect the pH, which means the only component that affects the pH is ammonium, which makes your solution going to be a little bit acidic. So your final solution is going to be acidic when you dissolve ammonium chloride into water. Okay. How? Let's look into that as well. This will come handy later on. So when you have this salt, ammonium ion is only going to affect the pH, so I do not care about chloride ion. Ammonium will react with water. Remember, water is what? HOH. Okay. This is a acid, right? So which means this has a one extra proton, which it is going to donate. Acids donate proton. It is going to give that to water, so water will become H3O plus, and this would become ammonia. And that is how you can see, because this is producing H ion in water, this is oh, this is not an acid. The solution is acidic. So that is how this solution becomes acidic in nature. Whereas if you take chloride ion, you mix it in water, it will accept the H and it will make HCl, but that is a very strong acid, so that usually doesn't occur. Let's take another example. If you have this, again, dissociate into its ions. The cation here is CH3COO minus, the acetate ion, and this is the sodium ion, so sodium acetate. Again, anion comes from, this probably is coming from CH3COOH, and cation, remember this is cation is a positive charge. This is coming from NaOH. This right here is a very strong base, which means this is going to be a very weak conjugate acid, and this does not affect my pH. This right here is an acid. What type? It is a weak acid. How do you know it? It's not part of the 6 strong acid, which means this is a weak acid. Because this is a weak acid, the ion that it has is a weak conjugate base. If this is a weak conjugate base, that means this will affect the pH. How? It's a base, so your solution will be basic. Okay, and if you are interested in figuring out this by a reaction, you can do that. COO minus, again, Na does not affect the pH, so I omit it. It doesn't participate. This is going to interact with water. Again, water is HOH, remember that, especially in acids and bases. This does not have a hydrogen it can donate, and it's a base. Bases, they accept proton, right? So this proton from water is going to be given to this, and it would become CH3COOH and OH minus. So this is a base and this is the conjugate acid. This is acting as an acid. This is the conjugate base. And because this, when you mix this ion in water, it produces OH ion, which means it is a base. So it's a basic solution. Yeah, you do not have to write the chemical reaction or think about the chemical reaction until unless the question wants you to use it. Okay, if the question is simply you have sodium acetate, tell me if your solution is going to be acidic or basic. You simply can do this part on the top and figure out that the solution is going to be base because it's a weak conjugate base. Okay, another example could be, so these are more examples of the same sort, but another example could be like this: ammonium acetate. So if I take ammonium, NH4CH3COO. Okay, so usually in this case we write CH3CO in the beginning, but let's say this is it. So what would this be? This would give you ammonium and acetate ion. Now what happens in these cases? Ammonium again comes from ammonia, which is a weak base, which means this is going to be a weak conjugate acid that will affect the pH, make it acidic. Similarly, CH3COO minus comes from CH3COOH, which is a weak acid, which means this would be a weak conjugate base. It's a base, and this will also affect the pH. So now you have two things that are affecting the pH. One makes it acid, the other one's making it the base. Now, if your solution will be acidic or basic, that would depend on the strength of these. Is ammonium a stronger acid in comparison to acetate, or is acetate a stronger base in comparison to ammonium? So now it's basically a tug of war. Whoever is stronger, your solution will be in the favor of that particular compound. If ammonium is a stronger acid, then the base strength of acetate, then your solution will be acidic. If this is stronger, acetate is stronger, then your solution will be basic. So that's what it depends on. You are not expected to know this. The idea, if I just don't give you any numbers, you can simply say that it's difficult to predict if the solution will be acidic or basic just based on the information given. Okay. So let's try a question. Predict whether a 0.1 molar solution of ammonium bromide will be acidic, basic, or neutral. So ammonium bromide will give you what ions? Ammonium ion and bromide ion. These are the two ions produced. Ammonium is coming from ammonia, which is a weak base, which makes ammonium a weak conjugate acid, which will affect the pH and it will make your solution acidic. Br minus comes from HBr, which is a strong acid, which makes this a very weak conjugate base, which means this will not affect the pH. So your solution is going to be acidic. Okay, now this is a question, but again, some things to remember here. Remember, because these are always weak, they will never produce anything strong. Okay, this is a weak conjugate acid. This is a very weak conjugate base. If they are producing anything, they are always going to be weak. Strong acid and strong bases are only those 6 of each that you have memorized previously. Okay, so now what you saw was basically just a qualitative question. Is it acidic or basic or neutral? Now I can also ask you calculate the pH of this solution. Along with that, Kb is given to you or Ka will be given to you. One or the other information will be given to you. For ammonia, Kb is this. Okay. Question is, what is the pH of a solution? So first thing you will always have to do is figure out, this is a salt. So is this salt going to make a solution acidic or basic? So we are going to repeat whatever you just did in the last question. This is coming from ammonium, this is Br minus, this is coming from HBr. So this is a strong acid, which means this is not going to affect the pH. Ammonium coming from ammonia, which is a weak base, which means this is a weak acid, which will affect the pH. So now I know this is acting as an acid. So I'm going to write a chemical reaction because I have to do the numbers now. So I need a chemical reaction for that. Ammonium ion is going to be reacting with water. How? It has this extra H that it is going to give to water because again it's an acid. Acids donate hydrogen ion, and it would become NH3 and H3O plus. Okay, so this is the reaction that is occurring. Now what does the question say? What is pH of 0.1 molar solution? So I know this is 0.10 molar. And this is, because it's a weak acid, this is going to be done in equilibrium, which means there is an equilibrium established. If I need to know the pH of the solution, I need to know what is the H ion concentration. Where is H ion? Right here. Which means I need to know what is the H ion concentration. And now you guys know, if any, if I need to figure out any concentration in an equilibrium reaction, the only way to do that is an ice table. So water here, these are aqueous because they are dissolved in water. All the ions are always aqueous. This is a liquid because it's just water. So if I need ice table, I don't care about this. What is the initial concentration of this? 0. Initial of this 0. What would be the change? I don't know, so I'll assume it is X. If this is a reactant, so it would be minus X. This is a product, so it would be plus X, plus X. Final equilibrium concentration would be 0.10 minus X. This would be X and this would be X. So now I have my equilibrium established. Now the question is, this is acting as an acid. This is an acid, and at the end we are producing H ion, which means what is this reaction? In this reaction, this is ammonium ion is acting as an acid. So this is a reaction of Ka. The equilibrium constant for this reaction should be equilibrium constant of an acid. Why? Because this is an acid. We just figured it out. This is acidic in nature. It's a weak acid. It's donating its proton, which means I need Ka. So in this equation, if I make the expression, it is going to be Ka equals ammonia concentration H3O plus concentration divided by ammonium ion concentration. Do I have this? Yes, X. Do I have this? X. X multiplied by X is X squared divided by 0.10 minus X. What I need is Ka. Is Ka given to me? No. In the reaction, what's given to me is Kb, and that is going to be the case every single time. Almost every time Kb will be given to you in such questions, whereas you need Ka. Okay, so remember this. If you're working with salts, most of the times the equilibrium constant will not be the right one that you really need. So if you're using the same equilibrium constant, check again. Okay, if you are using the equilibrium constant that's given to you in question, then please make sure that you want to use that equilibrium constant, because most of the times you are not using the right constant. This is a salt. What's given to me is Kb, but if you do this question correctly, you really need Ka, not Kb. How can I find Ka? Remember, Ka times Kb is 1.0 times 10 raised to the power minus 14. Dissociation constant, autoionization of water, right? So what is Kb? I want K, sorry, I want Ka. Kb is given to me. So what is Ka? 1.0 times 10 raised to the power minus 14 divided by Kb, which is 1.8 times 10 raised to the power minus 5. So you solve for this, find your Ka, and your Ka comes out to 5.6 times 10 raised to the power minus 10. And that's what goes here. Now you have your equation, and now you're using the normal rules that we usually use to solve for x. Okay, now you solve for x. How? Again, we'll assume that my x is a very small number, so I can reduce my equation to x squared divided by 0.10 is 5.6 times 10 raised to the power minus 10. If you solve for x from here, x is going to be square root of 5.6 times 10 raised to the power minus 10 multiplied by 0.10, which if you solve comes out to 7.5 times 10 raised to the power minus 6. So this is my value of x. If this is my x, I made an assumption here, okay, that 0.1 minus x is same as 0.1, which means I have to confirm my assumption. How would I confirm my assumption? X over initial concentration, which would be 7.5 times 10 raised to the power minus 6 divided by initial is 0.10, which gives you a value which is definitely lot less than 0.05, which means my assumption is correct. So I can use this value. Now I know my x. The question is not asking what is x, question is asking what is pH. What is x? X is H ion concentration. So my H ion concentration is this, which means what is my pH? I'll solve it right here. pH is going to be negative log of H ion, which would be negative log of 7.5 times 10 raised to the power minus 6, which gives you, oops, which gives you a pH of 5.13. So that is my final answer. Now I know what is the pH of my solution. That is the exact same process you need to follow for every single salt. As long as a question is asking what is pH of a solution and you see that it is a salt, there is no other way, you have to use this approach. Okay. Let's try another question of similar format, for example, like this. Now remember, because you're working with so many different types of compounds, and I'll keep on adding more, what you need to, first thing you need to do is whenever the question is asking what is the pH of this solution, figure out what do you have in solution. Do you have an acid, a strong base? Then the answer is simply pH is equal to negative log of H ion. Okay. If the question is asking about a weak acid or a weak base, then you know you have to make ice table. If now it is a salt, then you have to first figure out of the salt which of the ions, cation or anion, is going to affect the pH, and then do that particular question. Okay. For example, sodium acetate has application in photographic development and textile dyeing. What is the pH of 0.25 molar sodium acetate at 25 degrees Celsius? Ka is given to you as this particular number. Okay, so now I start with my acid. First thing, this is my salt. I have to recognize what is this. This is a salt. So I need to know which of these ions is actually going to affect the pH. So this is CH3COO. This is Na plus. These are my two ions. This ion is coming from CH3COOH, which is a weak acid, which means this right here is a weak conjugate base, which will affect the pH and will make my solution basic. Sodium ion is coming from NaOH, which is a strong base, which means Na plus is a very weak conjugate acid, which will not affect the pH. So the only component that affects my pH is this, which means I need a reaction of this in water. CH3CO minus is going to interact with water and produce CH3COOH and OH minus. Okay, so this is a negative sign, which means it needs a hydrogen and it's a base. Bases accept protons, so water will give its proton to this. It will make CH3COH, and water is, remember, HOH. H is gone, so what's left behind is OH. So that's how you get this OH ion as a product. Okay. Now, if OH ion is produced, meaning what is this reaction? This is acting as a base. So if I do this reaction, I need Kb. What's given to me is Ka again. See, so whenever you're working with salts, the right equilibrium constant will never be given to you. You have to make sure that you use the right equilibrium constant. Okay. Again, what's given to me is this is 0.25 molar, and the question is asking what is pH. For pH, I need H ion or OH ion. OH ion can be found from here, which means I need to solve for this. If you need to solve for any missing equilibrium concentration, you have to do the ice table. So ice table is the answer to most of these questions. How much water? We don't care. This is 0, this is 0 initially. Change would be minus x plus x plus x. Equilibrium will be 0.25 minus x, x and x. So you have all these concentrations now. If you can solve for x, you know your OH ion concentration. If you know OH, you can find H ion or you can find POH, whichever one, and then you can find the pH. So let's solve for this, which means what is my equation here? Remember, this is base. It's producing a base. It's acting as a base. So this equation, equilibrium constant, should be Kb. Kb is going to be x squared divided by 0.25 minus x. Kb is not given to me, Ka is given, so I'll have to solve for Kb. So let's do that separately. Remember, Ka times Kb is 1.0 times 10 raised to power minus 14. So Kb is going to be 1.0 times 10 raised to power minus 14. divided by Ka, 1.8 times 10 raised to the power minus 5. If you solve again, this would give you 5.6 times 10 raised to the power minus 6 minus 10. That's my Kb, which means this is equal to this value. So I solve for x. I'll make the assumption 0.25 minus x is 0.25. X is going to be square root of 5.6 times 10 raised to the power minus 10 multiplied by 0.25. Okay, again, I'm making the assumption here that 0.25 minus x is 0.25. So please make sure you understand how am I getting this x. If you don't, look back at some of the previous examples or the previous videos. X from here, if you solve it, comes out to 1.2 times 10 raised to power minus 5. So that is my x, which means because I made the assumption, I also will have to confirm my assumption. So x divided by I will be 1.2 times 10 raised to power minus 5 divided by initial, which is 0.25. This value comes out to be less than 0.05, which means my assumption is correct. So I can use this number. Now I know my x. My x is equal to OH ion. So OH ion is equal to x, which is 1.2 times 10 raised to power minus 5. So if I know my OH ion concentration, what can I do? I can go two ways. Either I can find POH, and then from here I can find POH, and then the pH would be 14 minus POH. Okay, or you can do this. H ion concentration multiplied by OH ion concentration is 1.0 times 10 raised to power minus 14, which means H ion concentration, because I want pH, so I need H, is going to be 1.0 times 10 raised to the minus 14 divided by OH, which is 1.2, 1.2 times 10 raised to the minus 5, which gives me my H ion concentration as 8.3 times 10 raised to power minus 10. This is H ion. If this is my H ion, pH is going to be negative log of 8.3. Oh, come on, 8.3 times 10 raised to minus 10. Sorry, I'm really low on space here. pH is going to be 9.08. That is your final answer. Okay, so remember, if you are solving for either H ion or OH ion whenever you need the pH. Okay, and if it is a salt solution, first identify which of the ions is going to affect the pH. Once you have that ion, you're going to figure out the pH by using that ion and making an ice. Rest everything else you have done previously in the previous half of this chapter. Okay, those are the only type of questions you can expect from the salt. There's nothing more to this. That is how you will basically be finding the pH of a salt solution. That is the only type of question you can get. If this is a salt, tell me what's the pH. And this is the only way to do it. Only important thing to remember here is that most of the times if it is salt, the equilibrium constant that's given to you in the question is not the equilibrium constant that you really need. If Kb is given, most of the times you need Ka. If Ka is given, most of the times you need Kb.